Okay, so in this short video, this is going to be based on U2A3. That's super messy. U2A3. It's all about multiplying and dividing monomials. Monomials are single terms. So, for example, 3x squared is a monomial, and so is 7x to the 5. So, when you multiply monomials, I like to think about it in two steps. First, I'm going to multiply the coefficients. So, 3 times 7 is 21. And then I'm going to multiply the variables. I've got x squared multiplied by x to the fifth, so I want to use my exponent laws. Remember that when I'm multiplying exponents with the same base, I add the exponent, so 2 plus 5 would be 7. So that's all there is to it, to multiplying monomials. Let's do just another example or two. Let's try this one. So again, I'm going to multiply the coefficients first, just like normal multiplication. Negative 4 times positive 9 is a negative 36. X cubed times x. Remember, if you don't see an exponent, treat it like a 1. Again, when I multiply exponents to the same base, I add the exponent. So I've got x to the power of 4. And then I have y to the power of fifth. There's no y here, so I'm just multiplying it by 1, so it just stays the same. So we'd have y to the fifth. So again, I want you to multiply coefficient first, and then kind of multiply each variable together separately. So first I do the numbers, then the x's, then the y's. Dividing works the same way. Again, as you get further into high school math, grade 9, 10, 11, 12, we are normally going to see division written like this, so it looks more like a fraction. And again, I want to do it the same way. I want to do the coefficients first. 18 divided by 6 is 3. X to the 5 divided by x cubed would be x squared. Remember, if I'm dividing powers with the same base, I'm just subtracting the exponent. So there's a little bit of review from the last unit. If I'm doing x to the fifth divided by x cubed, that equals x to the 5 minus 3, which is where I come up with x squared. Let's do another example. So again, I'm going to do my coefficients first. Negative 10 divided by negative 2 is positive 5. X to the 4 divided by x to the 3. Well, again, I subtract the exponent, so that's x to the 1, but we would just write x. And then y to the 9, that should be a y. I know it's not the clearest y in the world, divided by y cubed, so I do 9 minus 3, so it's going to be y to the 6. You could leave that with an exponent of 1, but it's convention in math not to write the exponent of 1 on a variable. The only other thing that might come up in your homework is what happens when my coefficients don't divide evenly into a whole number. So for example, 3 divided by 12, well, that would reduce the fraction to 1/4. And then x over 7, x to the 7 divided by x cubed would be x to the power of 4. Often the way you'll see this written would just be x to the power of 4 over 4. So I'm still including the exponent as part of the numerator. 1 times x to the 4 is x to the 4. So you may see in an answer key it written like this. It means the same thing, but this is a cleaner way to write it. I'll give you another example, kind of the same problem. So if I have 9 over negative 6, let's say y to the 8 over y to the 6. So then, well, 9 divided by negative 6, well, it's not going to work equally, but I will have 3 over 2. And I'm left with still a y squared in my numerator. Because I'm dividing powers to the same base, I just subtract. So that would be negative 3 halves times y squared, which is the same as saying negative 3y squared over 2. So if you wrote it like this, it's really the same idea. I wouldn't mark it wrong, but it's kind of our convention in mathematics. So that's all there is to multiplying and dividing monomials. Just kind of treat the coefficients and then each of the variables separately. Okay, that's all for now. Thanks for watching.